Good afternoon, Year 10. So we're continuing on today with one of the most important lessons in the homeostasis topic. Not just because it comes up on your GCSEs a lot, though it does, but also because it's extremely important for a large group of people. Now, we're going to start off with a nice easy starter, and I'm going to move on to learning about blood sugar homeostasis and diabetes. So 5 questions there. You just need to pause me and complete these at the back of your books, just the answers, not the questions. So hopefully you have done that. Where are the adrenal glands located in the body? You should have written on top of the kidneys. What is homeostasis? You should have written how the body maintains its internal conditions and keeps them constant. How do hormones target individual cells? Well, the individual cells have receptors on them, so that the hormones only attach to the cells that are their targets. What is the function of TSH? It's to cause the thyroid to release thyroxine. And why is the pituitary gland often called the master gland? Because it releases hormones which control all of the other glands and control their effects. An example is TSH, which controls the amount of thyroxine produced and is produced itself, TSH, by the pituitary gland. So let's move on to today's lessons now. Today we're going to learn about sugar homeostasis. And this is mostly going to be affecting your life in terms of diabetes. And you will all know of somebody with diabetes. You may know people in your family who have diabetes. And we're going to talk about what causes that today. So name the 2 hormones used for sugar homeostasis, one of which you will already know. Explain how negative feedback loops control sugar homeostasis, and hopefully remember what a negative feedback loop is from last lesson. And describe how diabetes can be controlled. That's a more interesting question. So, 3 questions here. I'd like you to write down the answers in as much detail as you can. I want full sentences. So glucose is used for what? Have a couple of minutes, 2 minutes. I'd like you to pause me, have a go at this. So, glucose is used for respiration in our bodies. Now in plants, it can also be used for making cell walls, but in our body it's fairly much only used for respiration, certainly at GCSE. How does it enter the body? You eat it. It's in the form of carbohydrates or simple sugars which you eat in your food. And how is it transported to the place where it's needed? In the blood. So it's absorbed through the digestive system, through the small intestine wall, and it's transported in the blood. Now, we have to control the amount of sugar in your blood, amount of glucose in your blood. And it's controlled by the pancreas. And we already learned a bit about the pancreas, or more accurately, we should have done. We definitely did in Year 8, and I don't think we got there in Year 9. But the pancreas, the other thing you need to know about the pancreas is, as well as releasing the chemicals, the hormones that control sugar homeostasis, it also releases digestive enzymes, proteases, lipases, carbohydrates that break down your food in the small intestine. So, it is a gland. It releases hormones to control blood sugar levels, and we're going to learn how that works now. So, get down the notes that are on the board. Pause me if you need to. You probably will need to. Then we'll move on to this. Now, I have provided you with a diagram in a Word document which is attached to this assignment. And what you need to do is you need to have that. You either need to copy that into your book. It's really just a simple drawing of a pancreas and a load of arrows. Or you need to print that. If I were you, I would just copy it. It won't take more than a minute. Probably take longer to print it. Up to you. I'd like you to listen to what I'm saying to you, and when I'm done talking, I'd like you to try to fill in that diagram. So listen to what I'm saying first, because it's relatively complicated, and then fill in the diagram. Now this is a big negative feedback loop. In actual fact, it's two negative feedback loops. One for if you have too much sugar, one if you have too little sugar. Too much glucose, too little glucose. So if you have too much glucose, high blood glucose, it causes insulin to be released by the pancreas. So the pancreas can detect when there is a high blood glucose and it releases insulin. And that goes around your blood and it goes to cells all around your body and it causes them to take in glucose and store it as a chemical called glycogen. Now could you please take down, because I've realised this is not on the screen at the moment, take down that word glycogen, 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 and that is how sugar is stored inside of our bodies. So in a lot of your cells around your body, but particularly in your fat cells, you have this chemical called glycogen. And glycogen is just a long chain of lots of glucose molecules stacked together and attached together. So if you have too much sugar, too much glucose in your blood, it's absorbed by your cells and added onto these chains of glycogen. So, if you have too much blood glucose, we'll say it again, it's detected by the pancreas releases insulin, that causes the cells around your body to absorb the glucose out of the blood and store it as glycogen. If you have too little blood glucose, let's say I had my breakfast, that was about 3 or 4 hours ago, I haven't had my lunch yet, my blood glucose is getting low, that's an issue too. If you don't have enough glucose around for respiration, that causes you all kinds of issues. In that case, the pancreas detects that as well, and it releases a hormone called, and this is confusing, glucagon. Glucagon and glycogen are different things. Glycogen, as we've just said, is long chains of glucose stored together. Glucagon is a hormone that is released when you have too little blood glucose, too low. That causes all the cells in your body to release glucose from their glycogen. So all that glycogen we stored up earlier, just after we had our Cookie Crisp for breakfast, all that glycogen will be broken down again and released into your blood as glucose. So they are opposites. Insulin is taking the glucose out of the blood and storing it as glycogen. Glucagon is taking the glycogen, breaking it into pieces, and putting the glucose back in the blood again. Either way, it's the pancreas controlling it all, and its aim is to get you a normal, balanced blood glucose level. So in a healthy person who doesn't have diabetes or any other condition related to that, if they have too much sugar in their breakfast, it will just be stored up, caused by the insulin. If they have too little sugar, it will just be, the glycogen will be broken down and you'll get more glucose. So it's almost impossible to have the wrong amount of glucose in your blood, unless you develop conditions like diabetes, and we'll come back to that later. So, from what I've just said, and feel free to go back and listen to me say it again, I'd like you to take these jumbled steps and labels, and I'd like you to put them in your diagram. Okay? So there are your labels, I'd like you to put them in your diagram. Pause me, have a go. Right. So, hopefully, if I pull up my version of the diagram, we'll have that one. You should have this diagram or something similar to it. Okay. So, if I have too high blood sugar, insulin is released. So the top one goes in this box here. It's just after the arrow comes out of the pancreas going upwards, insulin is released. If I have too low blood sugar, with the diagonal arrow going downwards, glucagon will be released. The next one was blood sugar. Now let's do it in order. So this one up here, after insulin is released, glucose is stored as glycogen. If that happens, just underneath that box, blood sugar will return to normal. Blood glucose will return to normal, and that will stop the insulin being released. So this is a negative feedback loop, because once the insulin has caused all the glucose to be taken away, that will therefore stop the insulin being released, because the pancreas will detect we haven't got too much blood sugar anymore. After glucagon is released, the glycogen will be broken down into glucose. So the very bottom box is glycogen broken down into glucose. And again, that should return the blood sugar to normal, because I had too little blood sugar, then I broke the glycogen down and turned it into glucose, so now I have lots of blood sugar. And again, once I have normal blood sugar again, it will stop the glucagon being released. So these are two negative feedback loops, where the chemical I release at the beginning leads to a chain reaction that then stops that chemical being released. The insulin stores up all the glucose as glycogen, which brings the glucose back to normal, which turns off the insulin. Two negative feedback loops. And the box in the middle should say pancreas, because that's a drawing of the pancreas. Fine. Hopefully we all got that. Now, to make sure that we've got this, the thing most people get confused about here is the words glucose, glycogen, and glucagon. The differences between them. So take a couple of minutes. I'd like you to write down these 6 words. You probably already have glycogen in your book, so I asked you to get it down. You could do the others though. Take a couple of minutes just to write down a definition for each of these words. Hopefully you paused me. Glucagon is a hormone released when blood sugar is too low, and it causes glycogen to be broken into glucose. Glycogen is how glucose is stored in human bodies. It's a chemical which is a store of glucose. Glucose is a type of sugar. Insulin is the hormone released when you have too much glucose, too much sugar in your blood. The pancreas is the organ, the gland, which releases glucagon and insulin. And homeostasis, we've said it 100 times, is how your body maintains its internal conditions, keeps them constant. Right, I'm going to play your video now, and I'd like you to watch that carefully, and there's going to be 5 questions. Probably best if you pause me before we watch the video, write down the questions, and then we'll watch the video, and you can answer them while the video's on. So just pause me, write down these questions, and then we'll watch the video.
Since my diagnosis. My name is Marco. I'm 18 years old, and I've had diabetes for 2 years. I love playing soccer, basketball, love being with my friends, anything outdoors. I love being active. I'm just a normal teenager. The symptoms leading up to my diagnosis were nausea, stomach pains, going to the bathroom, always thirsty. I would drink a glass of water, and 2 minutes later, I'm still thirsty. And I could really tell from there that something was wrong. Since my diagnosis, the support with my family has been incredible. Everybody's been there for me, especially my mom and my sister. They've really been watching over me and making sure I'm doing what I'm supposed to be doing. The first couple times I was pricking my finger and, taking the shots, it was kind of scary because I wasn't used to it, but to this day, it's nothing. It's one thing I have to do before I go to school. Check my blood sugar, take my insulin, and then at lunchtime and dinner, it's just a routine getting into. It's not too hard. If there's a problem with my blood sugar, I always have my insulin with me. When it's too high, I'll take insulin. And when my sugar's too low, I'll have either sugar tablets or a soda or juice or anything that can jumpstart my sugar and bring it back up. Exercise is important for diabetics. It's been a transition with diabetes because with soccer and basketball, I always have to check my blood sugar. For my diet, after my diagnosis, the only thing that really changed my consumption of treats and snacks. If you have diabetes, you can eat mostly what everybody else eats. You just have to be careful on how much it is, and you have to make sure you cover that with insulin. I get worried going off to college, leaving my parents. I won't have them watching over me as much, but I'm not gonna take it as a bumpy road. I'll take it as a challenge that I can overcome and can live like anybody else my age, just like a normal kid.
Okay, so if you haven't already, I'd like you to pause me and answer these questions. So, what are some of the symptoms of diabetes? How did Marco know he had it? So he was talking about being thirsty all the time. He was talking about needing to go to the bathroom a lot. He talked about a few symptoms there, but those are the main ones he focused on. How often do diabetics have to check their blood sugar? Now, this is dependent on the person, obviously, and it's also dependent on the type of diabetes, and we'll come back to that later. But he talked about having to do it in the morning, in the evening, and also before meals. How can diabetics increase their blood sugar if it gets too low? He talked about sugary drinks, fizzy drinks. How do diabetics decrease their blood sugar if it gets too high? He was talking about using his insulin. And how has Marco had to change his lifestyle to stop himself from getting ill from diabetes? So he was saying about focusing on the amount of treats he's eating, the amount of sugar he's eating, unhealthy foods, and also making sure that he exercised enough. Now, he had something called type 1 diabetes. And for the rest of this lesson, we're going to focus on the two types of diabetes, what they are, and how they can be treated. How can they be treated is the best way of putting it, probably. So, there are two types of diabetes. Now, type 1 diabetes is genetic. So he had a genetic condition. There's a misconception that everybody who has diabetes must be unhealthy, eating unhealthy diets, not exercising, because when we think of people who have diabetes, we're often thinking of those kinds of people. That's not the case for type 1 diabetics. You are born with type 1 diabetes. Often you don't find out you have it until later on in your life, usually in your early to late teen years. And this is because before that, you tend to be eating a very controlled diet anyway, and so your symptoms are not obvious. When you are 6 or 7, you're often not eating huge amounts of sweets, chocolates, snacks, because your parents are often quite careful with your diet. When you get to your teenage years and you're able to be exposed to this kind of food, then it will be more noticeable that you have diabetes. Now, you can treat that, it's caused by not producing enough insulin. So you are born with your body not making enough insulin. So your pancreas still detects, the blood sugar's too high, but it just doesn't respond in the right way. So you don't get enough insulin produced. And it can be treated, therefore, really easily with insulin injections. If your issue is, I don't have enough insulin, we have a cure, a solution, and that is inject yourself with the insulin which we can make. Now, a few years ago, it was not possible to make insulin. We're talking 100 years ago, early 1900s. And then diabetes at that point was a life-ending condition. You would die. But nowadays, we can make insulin. We used to make it from pigs. We now make it from bacteria. And we're actually going to study that in year 11. But either way, we can make insulin, and so there's no difficulty. It's not very pleasant, obviously, but at the very least, you won't die of type 1 diabetes. Type 2 diabetes is very much a different condition. It has the same effects, the same symptoms, but it's caused by different things and it's treated in a different way. This is where your cells have become overexposed to insulin and they don't respond to that signal anymore. This is, I've been having such high blood sugars for such a prolonged period of my life that my cells have become almost used to it. So the insulin is still traveling around your body when you're eating all your sugary foods, and after every meal there's huge amounts of insulin being produced. But your cells have started to ignore it. They've become acclimatized to it, so they don't do anything about it. Often this is caused by a poor diet and lack of exercise. That means insulin is going to be less effective. You still can do some work with insulin, but it's going to be less effective because your body already has enough insulin. The main way we treat type 2 diabetes is with exercise and a carbohydrate-controlled diet, i.e. not putting as much glucose in and using it up as fast as possible in respiration. So those are the two types. What I need you to do is I need you to take down these notes. So pause me and take down these notes if you haven't already. Fine. Now, I'm just going to skip over that. There's an activity I'd like you to do. Have a look at those two graphs, or rather the two lines on the same graph. I'd like you to tell me, firstly, what is happening here, describe the results, and secondly, can you explain the results? So the describe bit is easy. The describe bit is, well, I'm going to add some insulin. So you can see on the x-axis, we've got time after insulin addition. I'm going to add some insulin to people with type 1 and type 2 diabetes. And I'm going to record what happens to their blood glucose. And remember, from year 9, plasma is part of the blood. So, when you inject insulin into someone with type 2 diabetes, the description you can say is that it does not fall by much. The plasma glucose doesn't fall by much after insulin addition. But when you give it to type 1 diabetics, their blood glucose drops a lot and then slowly starts to rise again. So if you didn't understand that description, the fact that we're going to add insulin to people and see what happens to their blood glucose, you won't have been able to do the explanation. Now that I've explained that's what's happening, we're adding insulin, we're seeing what happens to the blood glucose. If you didn't get it before, have a go at the explanation. And the answer to the explanation is, people with type 1 diabetes don't have enough insulin, so that when you inject them with insulin, it causes their glucose to be stored as glycogen. People with type 2 diabetes already have enough insulin, their cells don't respond to it, and so injecting them with insulin has almost no effect on their blood glucose. Now, excuse me. Okay. You've got two 4-mark questions here. Now, we are changing the way we are marking this slightly. We're going to be taking in specific pieces of work. So for this lesson, I would like you to upload to Teams this exam question, either on a Word document or on a piece of paper, most likely your books. Just take a picture just of your answer and upload it to Teams. That will be marked by your teacher. So the first question is, explain how blood glucose is controlled in the body of someone who does not have diabetes. The second one is, compare how each type of diabetes is caused. Now, in order for this to be a complete lesson, I am going to go through the answers here. I would like you to be honest and upload what you actually wrote down. I'd also like you to give yourself a mark. Your teacher will then check that mark, make sure they agree, and make sure you've understood it. So, the mark scheme is going to be as such. Explain how blood glucose levels are controlled in someone who does not have diabetes. Well, we're going to talk about insulin and glucagon. If too high, insulin released from pancreas, 1 mark. So glucose is moved into cells or glucose is stored, or you could say it's turned into glycogen. That's the second mark. The third mark is saying that if blood glucose is too low, glucagon is released from cells. And the fourth mark is for saying that that will cause glycogen to be converted to glucose and released into the blood. So that's the first bit we did, that's the diagram we drew. Part B, compare how the types of diabetes are caused and how to treat them. Type 1 means you don't have enough insulin, whereas in type 2, cells don't respond to insulin, 1, 2 marks. Type 1 treated with insulin, type 2 treated with diet and exercise, or loss of weight, or drugs. We haven't talked much about the drugs. In all honesty, it's not really on the GCSE. Broadly, there are some chemicals you can take which will lower the amount of glucose in your blood. I don't want you to worry about that. I want you to focus on exercise, diet. The final question we're going to do today, and I don't need you to upload this one, is this question here. And then we're going to finish it off. Now, this is a 5 marker. First 2 marks are here. Right. Which drug A, B, C or insulin is most likely to increase blood sugar concentration in some people? Now, what we're looking at here is we're looking at which of these drugs is going to affect sugar homeostasis. And we know insulin lowers blood sugar. So injecting insulin is not going to increase your blood sugar concentration. The only other thing that matters here is the fact that B damages some cells in the pancreas. If we're damaging our pancreas, we're not going to release the right hormones, and that is going to increase your blood sugar concentration. So the answer is B, because the pancreas controls blood sugar homeostasis. Now that's relatively difficult. The ones I need to focus on are these next two, which you should definitely be able to do. And the first one is about digestion. If you didn't do about digestion in year 9, that would be more difficult, but still have a think about it. It should still be quite straightforward, and you should definitely be able to do the 2 marker at the bottom there. So pause me again, and then we're going to finish this off with this masking. So, drugs A, B and C can be taken as tablets. Insulin cannot be taken as a tablet. The reason you can't take insulin as a tablet is because it is a protein and it will be digested by the enzymes in your stomach and small intestine and broken down into amino acids. It won't work anymore. It's going to be digested is the answer. Other than using drugs, give 2 methods of treating diabetes. You could talk about diet, you could talk about exercise. And you could also, technically, on the mark scheme, talk about pancreas transplant. I don't think we want to talk about that, just talk about diet and exercise. Always diet and exercise straightforwardly. Now that's the end of that lesson. From our lesson objectives, we need to name the 2 hormones used for sugar homeostasis. You need to tell me that that's insulin and glucagon. Explain how negative feedback loops control sugar homeostasis. Really, that's just being able to draw that diagram, explaining what happens when you have too low or too high blood sugar. And then describe how diabetes can be controlled. That's telling me that we inject insulin for type 1 diabetes, we diet and exercise for type 2 diabetes. If you've understood those 3 points, you've got today's lesson fine. Well done, and I hope you have a great day. No doubt I will see you at some point in the hopefully not too distant future.